There are four main types of robotic arm geometry: rectangular, cylindrical, spherical, and jointed spherical. Robots with rectangular arm geometry use Cartesian coordinates and move linearly along each of the x, y, and z axes. This type of movement is also called 3P geometry, where the P stands for prismatic or linear motion. This type of geometry is most commonly used with pick-and-place or large overhead-mounted robots. Rectangular arm geometry robots can only move linearly in each direction. An overhead crane robot is a good example of this type of motion. It can move forward and backward, left and right, and up and down. Robotic arms that use Cartesian coordinate geometry generate a rectangular work envelope. Rectangular robotic arms have the simplest geometry and control system and are typically used in material handling operations. Cylindrical arm geometry robots move linearly in two directions and rotate in one other. Since this type of robotic arm moves in two separate prismatic or linear directions and rotates in one direction, it's given the designation of R2P, where the R stands for rotational. This type of robotic arm is most often used in machine tending, assembly, material handling, and palletizing operations. Robotic arms with cylindrical geometry move linearly in two directions. Vertical linear motion is called stroke. Horizontal linear motion is called reach. And rotational motion is called swing. Cylindrical geometry robots have a cylindrical work envelope. The advantages of this type of work envelope is a robotic arm reach that is deep at both the top and bottom of the stroke. Additionally, the robot structure allows for quick movements with high repeatability, a smaller use of floor space, and a larger payload capacity due to structural rigidity. Spherical arm geometry robots can rotate in two directions and move linearly in one, and thus are given the designation of 2RP. The robot has base rotation, shoulder rotation, and prismatic or linear motion at the arm. This type of robotic arm is most often used in machine tending, material handling, welding, painting, coating, and assembly tasks. Robotic arms with spherical geometry have rotational movement in two directions: rotational movement at the base and rotational movement at the shoulder. Spherical arm geometry robots also have linear motion in one direction, typically the reach of the arm. Spherical arm geometry robots have a mostly spherical work envelope at their outer reach, but are limited by the linear reach of the arm and the rotation of the shoulder joint. The shape of the robot's inner work envelope is almost conical and does not become a sphere until the arm extends. Spherical arm geometry robots typically have a very long reach and have proven their performance in industrial applications. However, their high cost, large use of floor space, and lack of flexibility compared to jointed spherical arm robots make it hard to justify in most industrial applications. Jointed spherical arm geometry robots have rotation in three directions, use revolute coordinates, and are given the designation of 3R. They are one of the most popular types of robotic arms and most accurately mimic the movement of the human arm. Robotic arms with jointed spherical or articulated geometry rotate on at least three axes. Left and right movements are provided by rotation at the base. Horizontal movement is provided by rotation at the shoulder, and vertical movement is provided by rotation at the elbow. Except for very close to the body, the work envelope of a jointed spherical robotic arm is almost entirely spherical. The advantages of this type of work envelope is a robotic arm with very deep reach, minimal floor space use, and high positioning mobility of the tool end arm. Due to its mechanical complexity and the complexity of its controller, this robotic arm typically comes with a higher hardware cost and requires skilled technicians.